Alright, welcome back to this video. In this video, we are going to look at modeling real life situation using curve fitting. Modeling real life situation using curve fitting. We are going to look at how we can relate or how we can relate all that we have learned so far and the the idea of getting the trig equations, the curve sketching and all that. We are going to see how we can relate a real life situation to model with trigonometric equations. Alright, in fact, you are going to love it. Without wasting my time, let's look at some examples. We are going to talk about 2 or 3 examples. Then we move on to another interesting part also. Very good. But don't forget that what we are going to do in this video is going to help you out in our next video. Very good. So let's look at the first example. Alright, welcome. So make sure that you have write down the question correctly. So now let's look at how we can go through the question for example 1. Very good. Very good. So now from the question we were given a table. Alright, on the table this is representing the month and this is representing the temperature in Fahrenheit. So this is January, February, March. Alright, so from January to December, we know that we have 12 months in it, alright, and that is making 1 revolution. Alright, and that is making 1 revolution. So in months, for 1 revolution, for 1 year, we have 12 months in it, and that is representing 1 revolution. So let's go on to solve the question. Now, don't forget that we are modeling real life situation using curve fitting. So we want to end up by getting the equation, alright, for the curve fitting so that you can sketch it. And most of it, you will be doing it yourself. So now, since I have taught you how to sketch curves already, alright, please, so that's how that is going to be. Now, the first thing that we know that this A represents the amplitude, then the B is for the period, then the C is the horizontal shift, then the D is the vertical shift. Very good. So, for you to get the amplitude, that is going to be amplitude, which is A, that is going to be maximum minus the minimum. That's going to be maximum minus the minimum over 2. Alright? Very good. So that is how we find the amplitude. Now, that is the maximum temperature. And the minimum temperature. That's what we are going to look for here. Very good. So, what is going to be the maximum temperature? So you go for the table, right? Go back and check the table where we recorded the highest value of the temperature for that month. So you can see that the highest value or the highest temperature recorded is 82, which was in the month of July, minus the minimum, which is 54. And that is in the month of January over 2, and this is going to give you 14. So that is how we get the amplitude. Then the next thing that we have to go for is the vertical shift. is the vertical shift, alright, and that is the D. So for the vertical shift, that is going to be maximum plus, instead of this is minus, this is plus the minimum over 2, and that is 82 plus 54 over 2, and that's going to give you 6, 8, 6, 8. So that is how we get the vertical shift. That is how we get the vertical shift. All right. Very good. Now, from the question, we are given that the coldest month is January. That is when X is equal to 1. Because you can see that from the table, January is the first month. Then we go to the second month, that's February. So we get to December, which is the 12th month. So, and the minimum temperature was recorded in the month of what? January. That is when X is equal to 1. So you can see that the coldest, the coldest month is January. When X is equal to 1. And the hottest and the hottest is July. So you can see that the coldest is January when X is equal to 1, and the hottest month is July. So you can count January, February, March, April, May, June, July. And that is the 7th month when X is equal to 7. Very good. So that is how we can do that. Now, with this, then it means that we can approximately choose our C. So we can approximately choose C to be equal to 4. That is approximately. Then we can approximately choose our C to be equal to 4. And that is representing the horizontal shift. Very good. So now what is the next one? We have our amplitude. We have our C, which is the horizontal shift. We have our D, which is the vertical shift. Oh, we are left with B, which is the period. Now, don't forget that. Let me do that here. Okay, we can clean for the first part. Which way we write it? All right. Now, don't forget that the period is 2 pi. Don't forget, this is sine. All right. So that's 2 pi over b. So this is going to be equal to. Okay. So now, but we don't know the b here. Okay. So what is going to be the b here? We know that from January to December we have 12 months. That is 1 revolution or 1 what period. So in that you can see that since the temperature repeats every 12 months, then our B is going to be 12, and that is going to be 2 pi over 12, and that is pi over 6. Then we move on to write our equation. So therefore, the equation will be equal to 840 sine S, the B is 12. Oh, sorry, please, the B is not 12, but the B is the period itself, that is the pi over 2. We just use this to find it. Plus the D, and the D is 68. Very good. So Now, having this equation for the curve fitting, we can now use this, we can now go and sketch this equation and see how it's going to be graphically or geometrically on and see how it is going to show geometrically for the curve fitting for the temperatures, all right, from January to December. Okay, so go for that yourself because we have done similar things like this before. All right, I'll be helping you to do the second one, but with this, I would like you to go and do it yourself. Very good, very good. Okay, see you for the second question. Your lecture. All right, welcome back. Let's look at the solution to the second question. Very good. Now the first question is that we have to write the equation. We have to write or find the equation. Very good. For the curve fitting. It's going to be simple. You know all that to go for. That is the amplitude, the period, the vertical shape, if any. Yeah, if any. Because not always that you get a vertical shape. If any. Then also what again? The horizontal shift. Very good. So let's move on. Let's move on. Now, from the question A, since it's a day, since it's a day, all right, the period. Now, don't forget that the second question, we are talking about time here, all right? We are talking about time here. And since it is a day, know that the period is going to be time. And how many hours do we have in a day? That is 24 hours. That is 24 hours. So this means that because we have 24 hours within a day. So this means that, very good. So this means that our B is going to be equal to 24 and the period is just going to be 2 pi. Please, this is the same thing, okay? Alright. So this is going to be 2 pi over B. And we are going to get 2 pi over 24. And that's going to give us pi over 12. Alright. Then we go for the amplitude. Then we go for the amplitude. So we have established the B. Let's go for the amplitude. You know that the amplitude is the maximum minus the minimum over 2. Very good. And from the question we can realize that the maximum temperature recorded during the day is, that is 85. 85. That is 85. 85. And the minimum is 61. 61 over 2. So the amplitude is going to 12. Then we go for the vertical shift. The vertical shift. So we go for the vertical shift. That is VS, the vertical shift. And that is going to be 85 plus 61. You have the formula already, and that is going to give you 73. 73. All right. So now we have to go for it again. I think that is all. So we can now go and write our equation. All right. So therefore, the equation is going to be f of s to be equal to the amplitude is 12. The amplitude is 12 sine the period is pi on 12. This is time, so we use t plus 73, which is the vertical shift. Very good. So that is going to be for the period. Very good. So now, with this, okay, the B is down, we have to sketch it. So let's go and sketch for the B. So let's go and sketch. So you can pause the video and do it yourself. Alright. So let's sketch. Alright, so B, that is the sketch. Now we know that the amplitude is 12. Okay? And we know that the equation is 12 sine pi over 12 t plus 73. Here, there is no shift. There is no horizontal shift here. Bear in mind that there is no horizontal shift here. Very good. Then the next thing that we can go for is the interval. 0 less than or equal to less than or equal to 2 pi. So this is pi over 12 t. So make sure we get t inside. So we multiply 2 by, let's multiply 2 by 12. Here is 0. Here is pi t. 12 times. So here is going to be 24 pi. Right? Then for us to get rid of the pi, we divide. So when we divide here by pi, then we divide here by pi, then we divide here by pi. So this will be 0 less than or equal to t less than or equal to, just to cancel this. So that's going to give us 24. Very good. Therefore, the interval is 0 to 4. Very good. So that is what we have for the interval. And this is the period. The period is, oh, so where is the period? I've seen that part. Alright, we know that already. So let's go for the sketch. Let's go for the sketch. Now, we know what we do for the sketching. Alright? We know what to do for the sketching. That is, we want to divide this into 4. Alright? So here we multiply 1 over 4 times 24. And what is this going to give you? Alright? And that is going to give you, so 24, that is going to give you, okay, that is 6. 6. Right? So we start, alright, so, okay. Okay, so let's go for the graph. Now, on the table, you know that we are starting at 0 to add till we get to 24. Alright, very good. So 0, then you add, you get 6, then you get 12. But I'm saying that we're not interested in the volume shape, but you can bring it. Then here is 12, and at 12 we have 73. At 18 we have that, and at 24 I will explain to you why we don't need the 6 and the 0. And at 24 we have, now you see, when you add 6 to this, you get 30, right? But what we are doing here is time, that is hours. So that means that we cannot write 36 like that. So with that, 36 will be the same as 6. So here, we now go back again, or let me explain it this way. We now go back again to 6, 12, then, but we are sketching for one period. So we just end at the 12. So let's see what the graph is going to be. At 12, 73. At 18, 83. At 18, let me check. I am going to, that is 85. 85 at 18, 85. At 24, 73. Then at 6, you are going to get 61. 61. So 61 will be here. And at 12, you are going to get 73. And that ends for one period. And that ends for one period. And that ends for one period. Very good. So you draw it nicely. You join it nicely like that. So that is what the graph is going to be for that. Now, bear in mind that at 12 o'clock, that will be the same as 0. And at 18, that will be the same as 6 p.m. And so it's like this, we start from 6, then we start from 6, then we start from 0, then we add the 6 like that. So 8 will be the same as 6 p.m. That is when you subtract 12 from it. Alright, when you subtract 12 from this, you get 0. Subtract 12 from this, you get 6 p.m. 24 is the same as 4 a.m. 6 is the same as 6 a.m. And 4 will be the same as 12 p.m. So let's answer the C. Alright, so the C, that for C is going to be the temperature hits 65 degrees Fahrenheit twice at 15 hours and 24 and 21 hours and 21 hours after 12 o'clock. After 12 o'clock noon, or at 3 a.m. and 9 a.m. So that's going to be your results or your response to the C question. Very good. So that is all. Thank you, and see you in the next video. All right. Oh, okay. Now, in the next video, we are going to use this idea again here about amplitude, vector shift, and all that, period, and all that, to do modeling with sinusoidal function. So that's going to be interesting, and I'm sure that is what most of you are waiting for, and you will love it. But don't forget the knowledge gain here. That's what you're going to use. Thank you, and see you then. Don't forget to subscribe.